1 farad, C3, let it be 3 farad, E1 4 volt, E2 let it be 2 volt. I want the charge on all capacitors. Initially uncharged, I'll switch on the circuit. I'll close the switches. Then we have to calculate the charge here. So first question, are they series parallel? See, our first aim will be series parallel. If not, we store network. If not, we'll go for alternative. Are they series parallel? So definitely they are not series, not parallel. Then what is the alternative method? Either the branch current method or distribution of charge solving the problem, or nodal analysis. I'll show both the methods. Parallelly, I'll show both today. Okay, let's go for the distribution of charge. The charge will flow from here, plus Q1, it'll go and deposit, minus Q1, plus Q1 charge from here. Then from here, I'll assume that one. Okay, after closing switch, no, I'll give another circuit. This is initially no charge in capacitor. You have to be very careful about any initial charge is there in capacitors. Any initial charge is there in the capacitor also. So timing, there is no initial charge in the capacitors. This is E2, this is E1. The plus Q charge minus Q1. What about the charge? Plus Q1 from here will leave. So from here plus Q2 charge, let it enter. So here Q2 minus Q2. So Q1 plus Q2. So that you show it here. So this is C3, C1, C2. Okay, this is a distribution of charge. I think you should be and when you're distributing charge, you have to be careful about conservation of charge principle. So how much of charge here? From here, Q1 charge, here Q2 charge will flow. And how much of charge will come here? Q1 plus Q2 will leave. And what about this plate? Negative charge. Like this, you go for the distribution of charge. So you have to see that charge of a cell must be conserved. What charge left? Plus Q1. Whatever you do again there, it should be how much? Again, the same charge should enter the negative terminal. And then one very important thing you notice here. What is that? This junction. Look at the charge of these plates. Must be conserved. Charge of these plates must be conserved. No? Isolated junction. So what was the initial charge? 0, 0, 0. Final charge should be 0. This is going to help you to distribute charges. How to distribute charges? You have to take care about this one. What was the charge at this point? Minus Q1, minus Q2, plus Q1, plus Q2. So what was earlier charge? 0, now also 0. So when you're distributing charge, this condition is very important. Charge at isolated junction must be conserved. Fine. Okay, now write loop equation. So plus C1, looking at the circuit, plus C1 minus Q1 by C1 plus Q2 by C2 minus E2 equal to 0. So E1 is 4, Q1 by 2, Q2, C2 is 1, E2 is 2 equal to 0. So this will be
plus Q2 by C2, sir.
Plus Q2, no? Yeah. So this will become 4 minus Q1 plus 2Q2 equals 0. There's a one equation. Two unknowns are there. One more equation. So you can either prefer this slope or this slope. So this will be plus C1 minus Q1 C1 E1 will be 4, Q1 2, C3 is 3. Four minus, so this will be 5 Q1 by 6 minus Q2 by 3 equal to 0. Solving these two equations, we'll get the unknowns. Okay, further, I think I can simplify further this. 3 will take common. 3 it will be 12 minus 5Q1 by 3 minus Q2 0. Solving equation 1 and 2, we'll get the charges in all the capacitors. Now, after getting this, I want the potential difference. So like potential difference means something like this, AB. How to calculate VAB? This is very important. As we go for next chapter, RC circuits, this finding out potential difference is what the whole numerical solving in the RC circuits. So how to get the potential difference? VA minus Q1 C1 plus Q2 C2 minus VB equals this. Substitute Q1 Q2. Sir, if I get Q2 negative, change polarity, put Q2 here negative. Don't again redraw one more circuit. Where all Q2 positive. Okay, fine. If Q2 negative, no, substitute everywhere where all Q2 is there, put negative sign, then you conclude it here. Anybody value Q1?
Sir, it should be 5Q1 by 2, sir, in the second equation.
Oh, this is 2.
Q1 14 by 3, Q2 is 1 by 3.
14 by 3, 1 by 3.
14 by 3, 1 by 3. So I got positive. What does it mean? Both the batteries are discharging, no? So you write that also. Both the batteries are discharging or supplying. Supplies energy. Here also supplies energy. And then what about the heat generated? Will there be any heat generated? Only one capacitor cell is everywhere. What happens? The circuit will be heat generated. Again, the initial energy in the circuit, no initial charges. No initial charges in capacitor. This condition is very important. No initial charges in capacitor. Okay, fine. Now, what is the UI? Work done by cell equal to UF plus heat generated. What is work done by cell? Q1 into E1. Both the cells does positive work. Solve for H, will get the required answer. So this is a method of getting the heat generated. So what we have to do, we should trace out the flow of charge in each circuit. In each branch, what happen, how much of charge has flown. So that has to be traced out. Okay, I think I shown complete circuit. You just make observation here.